Collaborations are so important to my work. My background is in radiation oncology and radiation biology, and so embarking on this new area of cancer immunology and immunotherapy, I rely heavily on my collaborators. I work with Dr. Steve Dow and Dr. Dan Regan, and they have been incredible at teaching me about cancer immunology and immunotherapy and trying to integrate that into the radiation field.
Dr. Boss brings radiation expertise and we bring the immune expertise, and we jointly design the projects. We each contribute our portions. We figure out what needs to be done by each lab, and then we create the study design and the study protocols, and that's how science is done nowadays. You can get a lot more done more efficiently because you eliminate a lot of the redundancy, and it works faster. It's a much better way of doing science.
Radiation oncology is one of the pillars of treatment. Radiation therapy is excellent at killing tumor cells, but for certain tumor types and patients, unfortunately, it's not curative. So we want to try to find ways to improve outcomes even more. Radiation in killing tumor cells can stimulate the immune system to come into the tumor microenvironment and do really positive things to have another level of tumor cell kill. But it can also bring in some immunosuppressive cells that can counter those positive effects. So there's evidence where combining radiation therapy with an immunotherapy combination to boost the positive effects may have better outcomes for patients both in the locally irradiated tumor field, but then also possibly throughout the body at other metastatic sites.
Some of this work has come from our earlier work with bone cancer and immunotherapy, and it just sort of made sense that radiation does trigger an immune response. If we could amplify that response with the immune therapy we're using for bone cancer, that the two together would give us a better outcomes.
And then we've also optimized a really cool approach of analyzing nasal tumors and immune effects by flushing saline in their nose, collecting the cells, and then analyzing the cells up in the lab to characterize the different immune responses.
It's a new treatment potentially for dogs with nasal cancer, really an unsolved problem in dogs. And it turns out that there's a small subset of humans that develop nasal cancer also. So what we do know is that we have a much better understanding of how radiation therapy impacts the immune response in the nose. It becomes a platform, right? So we're already looking at this for brain cancer. We've been looking at it for bone cancer. I think it could be more widely applied to other types of cancer. So it's not just nasal cancer, it extends beyond that.
Every dog we enroll or every archive sample we analyze, we learn so much, and I think that's what keeps us going every day, is seeing how all the science comes together, and I can't wait to see the results, and I'm optimistic that we're going to find something really interesting here.
I think for the next year we really want to see how the immune response changes when the drugs are added to radiation, and then 5 years we want to see significantly extended survivals for both our dogs and our human patients.
If we can find positive outcomes in dogs and translate that to people, that's our ultimate goal.